All right. So this is gross anatomy, and we are talking about joints. A joint is a point where two bones are going to be able to meet. Now, when you are classifying joints, you can classify them generally in three ways. You can say joints are biomechanical, that is one classification. Can as well classify them anatomically. If you talk about anatomy, you are simply talking about a structure, so that is structurally. And then you can as well classify them physiologically. That is, if you're talking about physiology, you're talking about function. Now, anatomically, you can classify joints to be either fibrous, cartilaginous, or synovial. While physiologically, you're classifying them depending on their function. If you look at the anatomical classification, the fibrous, cartilaginous, and synovial, this is just to do with a kind of connective tissue that they have. That is a structure, the type of connective tissue joining the bones. Fibrous, cartilaginous, or synovial. Physiological is the function. How much movement can this joint allow? So you have got synarthrosis, amphiarthrosis, and diarthrosis. So let's start with the biomechanical classification. In the biomechanical classification, we are classifying joints as either being simple joints, compound joints, or complex joints. A simple joint has got two articulating surfaces, for example, the shoulder or the hip. So you have got one part, let's say we're talking about the shoulder. You are going to have the end of the humerus articulating with the glenoid fossa. You have got what we call the glenoid fossa in the scapula. So there are only 2 points where the joints are actually meeting. Compound joint is going to have three or more articulation points. For example, the radiocarpal joints. If you touch your wrist, that is where you're going to have the radiocarpal joint. So you don't only have two bones meeting. And then a complex joint is going to have two or more articulation surfaces plus an articular disc or a meniscus. Now, for example, if you look at your knee, a meniscus is there because you want to protect muscles. It's more like these are things that are going to be there to more like for cushioning to prevent the muscle from wearing out as it is getting to rub through the joint like that. Physiological classification, remember we said that we are classifying depending on the function or the amount of movement allowed. The first one we talked about was synarthrosis. A synarthrosis, actually I use the mnemonic SAD, SAD. The S, which is a SAD, that is the synarthrosis, there is no movement. The A, antiarthrosis, there is little movement. And then the D, diarthrosis, there is total movement, SAD. So synarthrosis is a type of joint which allows no movement at all. So this joint is actually going to be fibrous. So when you are comparing the way we are classifying joints anatomically and physiologically, synarthrosis joints are actually fibrous joints because fibrous joints don't also allow movement. Now, if we say fibrous, we are just talking about the kind of connective tissue. So when you have got a fibrous connective tissue connecting two joints, they don't allow movement. Amphiarthrosis allows little movement. So the kind of cartilage you expect, the kind of connective tissue you expect is cartilaginous. Diarthrosis allows movement in almost all directions. So the kind of connective tissue you're going to see is synovial. Okay, so that is a relationship anatomically and physiologically. So when you're talking about a synarthrosis, these joints which allow no movement, we can classify them generally into three. The first one is syno, synostosis. Now, if you can see, all of these are ending with SIS at the end, or the synarthrosis joints. Synostosis is a kind of joint that allows no movement. It's actually found in older adults. And this one, we are going to find it on the skull. Remember, we talked about the sutures of the skull? These sutures don't allow any movement. So, a suture is an example of synarthrosis, and we call it synostosis. And then we have got a synchondrosis. A synchondrosis is a kind of joint where the type of cartilage that you are using is hyaline cartilage. We'll talk about the different types of cartilage. You've got hyaline cartilage, elastic cartilage, and fibrocartilage. In a synchondrosis, we don't use fibrocartilage. Instead, we use hyaline cartilage. For example, when you are eating the bone of a chicken, at the end of the bone, at the end, there is that come part that you enjoy, that come apart at the end of the bone, that is cartilage. All right, so hyaline cartilage. Now, a synchondrosis is going to be found specifically on the epiphyseal plate. When you look at a long bone, we talked about a long bone, remember, there is that point on a long bone where growth is going to be permitted. That is what we call the epiphyseal plate, also known as the growth plate. So we have got hyaline cartilage there. That is why growth can happen. If there was no hyaline cartilage, then growth wouldn't have been happening there. Okay. So epiphyseal plate is an example of a synchondrosis, which is a synarthrosis joint. And also in adults, because the epiphyseal plate is actually going to be found in those people who are able to grow. Those people who can't grow, who have already grown, cannot have the epiphyseal plate because it closes. Like somewhere above 20, then it will close. You can no longer grow. You also have a synchondrosis between the first rib and the sternum. Remember last time? Okay, I'm remembering something else. So we didn't talk about this, but we should have, and we'll talk about it. So the first rib is going to be attached to the sternum. Actually, we talked about it, I remember. We talked about the sternum, we talked about the ribs. So the first rib is attached to the sternum via a synchondrosis. Remember, synchondrosis, you have got the epiphyseal plate and the first rib attached to the sternum. Please never forget that. And then we also have a syndesmosis. Syndesmosis here, what we are going to have is an interosseous membrane, actually the interosseous ligament, which is very dense connective tissue. It is actually dense connective tissue. We'll talk about connective tissue. If we say dense connective tissue, means that you have got collagen fibers. You understand that anyway. So in a syndesmosis, there is only a little amount of movement which is permitted. For example, you have got the distal tibiofibular joint. So if you look at your leg, if I say leg, when you look at your lower limb, you are going to have the thigh. After the thigh, you are going to have the leg. After the leg, you are going to have the foot. So on the leg, you have got two bones, the tibia and the fibula. Now these two bones, they are going to connect on top on the knee joint, and then they are going to also connect down Okay, they're also going to connect down. Now, down where they are connecting, that is where we say we have got a tibio-fibular joint, because the tibia and the fibula are connecting. So that is a distal tibiofibular joint. It is a syndesmosis. It barely can move, but it can have little movements. Is this okay on the synarthrosis? Okay, good. And then amphiarthrosis. Amphiarthrosis is going to allow limited mobility or limited movement. I remember we talked about to say amphiarthrosis is going to have cartilaginous joint. Cartilage in this case is talking about the kind of connective tissue. So when you're talking about the anatomical classification, it is going to relate to the amphiarthrosis. An example of a joint that can allow little movement is symphysis. Please don't confuse these, don't confuse them. Here we have got a synostosis, chondrosis, and the syndesmosis. Please make sure that you know examples of each one, please. These ones specifically I've listed here. Make sure you know them. And then for amphiarthrosis, we have got a symphysis. Symphysis is a joint that is going to be found on the midline on the middle of the body. Like between all the vertebrae bones, you are going to have the intervertebrate disc. So that joint can allow little movement. That is what we call a symphysis. Also on the pelvic bone, the left pelvic bone is going to be connected to the right by what we call the pubic symphysis. It is also an amphiarthrosis. And then a diarthrosis is a joint that can freely allow movement. And synovial joints are examples. Examples that we can talk about, joints that can allow total movement. You can even feel yourself. You have got the shoulder joint, the elbow, the ankle, the hip. All these can allow total movements. They are synovial. Now, when you're talking about the anatomical classification of joints, of course, we know we have got 206 bones, and in the body, we are going to have 360 joints. And we can classify them as being fibrous joints anatomically, cartilaginous joints, and synovial joints. Fibrous joints, remember we said that these joints correspond to synarthrosis, they don't move. And to be specific, if you look at this joint here, this is like the joint that holds the teeth in place. I'll mention the name. That's known as a gomphosis. And then you have got cartilaginous joints, which will allow some little movement, not fully. And then you have got a synovial joint, which is correlating to the diarthrosis when you're talking about physiological or functional classification. Starting with a fibrous joint. Fibrous joints are going to have fibrous connective tissue. Fibrous connective tissue is very much strong, and so it will not be able to allow any movement. Examples of fibrous joints, we are going to have a suture, a gomphosis, and a syndesmosis. A suture is a joint on our head holding the bones of the skull. Gomphosis is a joint that holds our teeth in the socket, holding them in the bones, our teeth. That's a gomphosis. And then syndesmosis is a type of joint where you have got a strong ligament getting to attach the bones. And we already talked about a syndesmosis. For example, you have got the distal, also known as inferior tibiofibular joint, because the proximal is also known as the superior because it's on top. And when you are talking about here, we also mentioned that is syndesmosis distal tibiofibular joint. So that is also an example here. Remember, fibrous joints are actually synarthrosis. You also have the sacroiliac joint. So the sacrum, which is the end of the vertebral column, is going to be attached to the ilium, which is one of the bones of the pelvic bone. So that joint between the sacrum and the ilium, sacroiliac joint, movement does not really happen there. So you can see this is a suture, this is a syndesmosis. Look at how these bones are completely held together by interosseous ligament. If we say interosseous, osseous means bone, inter means between. So this ligament is between two bones. That is a syndesmosis, and we're talking about distal. So at the end here, not proximal, not at the top. And then you have got a gomphosis. A gomphosis is a joint which is holding teeth in the socket here. Is that okay?
Okay.
And then we have got cartilaginous joints. Cartilaginous joints, instead of being held by fibro cartilage like the fibrous joints, these ones are joined by either hyaline or fibrocartilage. Right? Take note of that. These, we said, they are held together by fibrous connective tissue. These are going to be held by hyaline cartilage or fibrocartilage, and they'll be able to allow some little movement. Okay. What are the examples of cartilaginous joints? We have got primary cartilaginous joints and secondary cartilaginous joints. The primary cartilaginous joints are also known as synchondrosis. Synchondrosis. Secondary cartilaginous joint is also known as symphysis. We already talked about symphysis, right? Those which are found on the midline. So primary cartilaginous joints, these are joints where bones are joined by hyaline cartilage, or where bone is united to hyaline cartilage. So two bones can either be held by hyaline cartilage, or a bone is going to be held connected to hyaline cartilage. And examples of chondrosis or primary cartilaginous joints, we have got a permanent cartilaginous joint and a temporary, a permanent chondrosis or primary cartilaginous joint and a temporary. Permanent means that they don't ossify. To ossify means to get to, this is a process by which bone gets to actually form and get to become bone, strong bone. So these don't become strong bone like that. For example, the first sternocostal joint. First sternocostal joint, this is a joint between the first rib and the sternum. We also mentioned it here. Where is that? This one is a synchondrosis. The joint between the first rib and the sternum can allow no movement. Same with the physioplate. So, first sternocostal joint, please make sure that you know. First sternocostal joint is a synchondrosis. It is a permanent synchondrosis. It does not ossify. Bone does not form between the first rib and the sternum. There is only cartilage there, actually hyaline cartilage. Now, temporary synchondrosis means they can ossify. They can actually become bone. For example, the growth plate, also known as epiphyseal plate. The growth plate is made up of hyaline cartilage, but as we get to grow, the hyaline cartilage is going to be replaced and is going to become bone. So it completely becomes bone and the person can no longer grow like that. A secondary cartilaginous joint, also known as a symphysis, is going to be joined by fibrocartilage. Primary is joined by hyaline cartilage. And these are all found on the skeletal midline. For example, between the vertebrae bones, between C1 and C2, C2 and C3, C3, C4, like that. Okay, intervertebral disc. Also, the pubic symphysis connecting the two bones. Yes, please. Okay. So you can see this is a growth plate here. It is a temporary synchondrosis because later on this hyaline cartilage you can see here will become bone and the bone can no longer grow. And then the symphysis, you are going to have this one on top that you can see here is uh, a primary, okay, synchondrosis. Primary synchondrosis between the first rib and the sternum, this one cannot grow. Now, forget about this thing on top here to say symphysis. Okay, this is a primary synchondrosis. And then this one here is a permanent synchondrosis. This is actually what is supposed to be this one found on the midline. This is supposed to be a symphysis. Symphysis is a joint found on the midline. Alright. Permanent synchondrosis is supposed to be the first sternocostal joint. Let me just mention that again. First sternocostal joint is permanent, it cannot ossify. This joint cannot ossify. This one, this side, the growth plate can ossify, so it is temporary. So this thing I had written permanent here was supposed to be on top here. And then the symphysis is now supposed to be this one, which is here on the midline, right? And then we have got synovial joints. Now, synovial joints will allow total movement, alright? They allow movement in whatsoever direction. All synovial joints are going to have some common characteristics that you have to know. A synovial joint is going to have articular cartilage. Articular cartilage is a cartilage at the end of a bone for it to be able to connect to another bone. So articular cartilage is a type of hyaline cartilage that covers the end of both bones. Okay, one bone is connecting with another bone. The ends of these two bones are going to have articular cartilage, which is a type of hyaline cartilage. And these ones just provide a smooth articular surface, and the aim is to reduce friction. A synovial cavity, also known as a joint cavity, is going to be a space which is going to be made by the articular capsule and is going to be filled by synovial fluid. Synovial fluid is important also for friction, alright? And then you are going to have the articular capsule. The articular capsule is a sleeve of fibrous tissue which holds bones together. It is going to be made up of the fibrous, which is the external dense connective tissue, and the synovial membrane. Let's just see that. You can see this is a synovial joint. Look at the parts. You have got a muscle. The end of a muscle is going to be a tendon which connects to a bone. Emphasis is just where a tendon connects to a bone. You also have a ligament. A ligament connects two bones. You have got bursa here. Remember we talked about bursa last time? Bursa is there and you're going to see it on joints so that a muscle will not be rubbing to the bones because it can wear out. So that's the function of the bursa. It contains synovial fluid to prevent the wearing out of a muscle when it presses very much on the bone. You have got the articular cartilage. The articular cartilage is found on the ends of the bones. You have got the synovial cavity, which contains synovial fluid inside here. Okay, so that is it. So this is just another one. Please make sure that you are able to label. Okay. Now, synovial joints can be classified into 6 types of joints. A synovial joint can either be a ball and socket, a hinge joint, saddle joint, ellipsoid, also known as condyloid, pivot, a plane joint, also known as gliding joint. Starting with the ball and socket, you can see a ball and socket. Okay, let's describe this. Look at the ball and socket. You can see you have got one end of the bone is rounded, while the other end is more open for the other end to fit in. So this kind of joint is multaxial, m- meaning that it can allow movement in all directions. Axial means movement in a certain axis. So it can allow movement in all axes. That is a multaxial ball and socket. For example, look at your elbow. Not your elbow, but on your shoulder. Your shoulder or your hip joint. You can move in any direction on those two joints. Right? So that is it. Multaxial. There is a lot of movement permitted. Look at how a hinge is. You can just move forward or back like that. Look at how a saddle joint is. You can either move this blue thing on top there in these directions, or you can move the red one. Okay, think of how a horse is. When you are jumping on a horse, you can get one of your legs and take it the other side of the horse, and the horse can actually move up. Okay, it can move up and do not be able to fall. So you can move the blue one like that. You can as well move the red one. And then a pivot, you can actually get to rotate. Condyloid is more similar to ball and socket, but it allows limited movements. A plane joint, just from the word plane, can only, that's why we also call it as gliding, can only allow sliding movements. Okay, so you need to make sure that you know which ones are multaxial and which ones are biaxial, which ones are uniaxial. A hinge joint, a pivot, and a plane, these are uniaxial, meaning that they can only allow movement in one axis. For example, uniaxial, for example, a hinge. You know how a hinge is. You can just straighten, you can just flex or extend, flex or extend. That is only one axis. A pivot, you can only rotate. That's all. That is also one axis. And then a plane joint gliding, you can only slide. That's all. That's one axis. But an ellipsoid, you can slide in this direction or the other direction. Same with biaxial. I mean the saddle. Okay. Let's just describe this. Starting with a plane or gliding joint, the only movement allowed here is gliding. So you can actually get to slide like that. An example of a plane joint that we can give is a sternoclavicular, between the sternum and the clavicle. The sternum and the clavicle can actually get to glide over each other. Acromioclavicular joint, the acromion of the scapula and the clavicle, intercarpal joints. You can see these bones that you can see here. These are carpal joints. So between these are carpal bones. Between the carpal bones, the kind of movement that you can only see there is that these bones can only slide against each other. So that is what we call intercarpal joint, and it is a plane joint. You also have some other ones like the sacroiliac. okay, that between the sacrum and the ilium. And then a hinge joint is also known as a ginglymas. A hinge joint can allow flexion and extension. Remember, hinge joint, just like plane joint, is also uniaxial because it can only allow motion in one direction. Either you flex or you extend, all right? For example, we have got our interphalangeal or humeroulnar joint. Between the humerus and the ulna, the ulna, this is the bone of the hand, actually of the forearm, okay, the forearm, because you are going to have arm, forearm, and then hand at the end. So your forearm, when you look at your hand, you have got a little finger and then the big finger. On the side of the big finger, you are going to have the radius. On the side of the little finger, you are going to have the ulna. So between the ulna and the humerus, you have got this joint, humeroulnar, which we also call as the elbow joint. So the elbow joint, you can just straighten it or extend it. You can even try. You can only straighten it or extend. So that is flexion and extension. To extend is actually to straighten. To bend is to flex. So that is a hinge joint. A pivot joint, also known as a trochoid, pivot can only allow rotation. Okay, so it is also uniaxial. Look at how it's supposed to be. For example, the radius will fit into the ulna. This is a proximal radioulnar joint. Okay, you can see how it fits in. It can only rotate. And also the atlantoaxial. Remember we talked about this to say that we can turn our head left or right because of the atlantoaxial joint. And then the condylar, also known as condyloid joint, this one can allow flexion or extension like that, but then it is biaxial. Okay, for example, you have got the temporomandibular joint. The temporal bone is this one, and then the mandible. So this joint here is condylar. And then you have got also the atlanto-occipital, that joint that allows us to to say yes with our head. You move your head up and then down. So that one is also condylar. Look at how it is supposed to be. You can actually rotate in this way. You can as well at least slide a bit like that. So that's why this joint is biaxial, because movement is not only allowed in one direction. And then you have got the ellipsoid. Ellipsoid joint allows movement in many directions like flexion, extension, abduction, adduction, and also circumduction, because when you combine flexion, extension, abduction, adduction, that will give you circumduction. An example that we can give here is a radiocarpal joint. This is the radius, and then these are the carpal bones, the scaphoid and lunate. To talk about these bones. Okay, so this can actually allow flexion, extension, adduction, and abduction or circumduction. But the thing is that you cannot rotate here, because if rotation was possible, the joint would have become ball and socket. It means that it would have been multiaxial, but this one is just biaxial. So there is no rotation. It is so similar to the ball and socket, except there is no rotation. You also have the saddle joint. Actually, mostly when you look at where is the saddle joint? Okay, here is the saddle joint. Here on this we are discussing, I've split the condyloid and the ellipsoid, but they are actually supposed to be the same. EC, okay, the ellipsoid and the condylar. These are supposed to be more of the like the opposite, just the opposite terms. But here we can actually get to split them to be more specific. But in some other books, you'll find it like that. The saddle joint, also known as the sellar joint, is going to allow movement in two planes at right angle to each other, accompanied by some axial rotation. Look at this. You can rotate a bit. If you hold on the top here, you can actually move this a bit this side or this side, but then mostly these things are supposed to be moving 90 degrees from each other. This can actually move from left to right like that, okay, like that, moving 90 degrees from each other, but there is little rotation that can be allowed. An example is the first carpometacarpal joint, okay, carpometacarpal. So these bones that you can see here are carpal bones, and then these bones that you see just on top of them, they are metacarpal joints. So that joint there, especially on the first one, that is the saddle joint. And then we have got also calcaneocuboidal joint, the talocrural joint, which is also known as the ankle joint. Look at this here. We are saying talocrural is going to be between the talus, which is this bone on top here, with also the tibia there to form the ankle joint. So this joint here is going to be a saddle joint. There is only little rotation. Mostly movement is going to be at right angle to each other. Calcaneocuboidal is between the calcaneus and the cuboid bones. Some of this you'll not understand, but you get to understand them when you talk about these bones, right? And then now the ball and socket. The ball and socket, you are going to have a cup-like concavity, which is known as a socket, which will receive a globular head, which is known as a ball. So this kind of joint allows circumduction and any movement. It's the only multi-axial joint. And there are two examples. The hip joint, which is also known as glenohumeral, the hip joint and the shoulder. The shoulder is what is known as glenohumeral because the humerus, the head of the humerus is going to fit on the glenoid fossa of the scapula. So that is why we call it a glenohumeral. And this glenohumeral joint is very much likely to be dislocated. Why? Because the head of the humerus is actually big. It doesn't fit exactly into the glenoid fossa. Only one third of the head will be able to fit in the glenoid fossa. So that is why on the shoulder you can have a lot of movements, but the joint is not stable. But on the hip, you cannot rotate your hip as much as you can rotate your shoulder because the head of the femur more fits into the acetabulum. So acetabulum is this part of the pelvic bone where the head of the femur will be able to fit in. Okay, so that is the ball and socket, also known as sphenoidal joint. So these are joints that you need to know. Please get to try out these if you can be able to answer them. If you can't, you go back again to see where you have not understood. Make sure that you understand.